So another type of real probability we'll be coming across, and this is probably going to be more what we'll use in the future, is more like this type of data. So finding an empirical probability, again, by definition, empirical or statistical probability is based on observations obtained from probability events. The empirical probability of event is going to be the relative frequency of the event divided by the total frequency. So it looks awful familiar to classical probability, except now the information is coming from observations. We're collecting the data a little bit differently. So, but notice how we have the frequency of the event divided by the total frequency. So we've heard those words before. So let's look at and again, when we talk about empirical probability, since the frequencies are different, there's not this equally likely likelihood. The probabilities will be different from each one based on the demographics of the material. So a company is conducting an online survey of a randomly selected U.S. adults to determine how they read books during the last year, if at all. So far, 1,490 adults have been surveyed. The pie chart shows the results. Note that digital books includes ebooks as well as audiobooks. What is the probability that the next adult surveyed read only print books during the last year? So based on this data, we're going to make a prediction. The next person they survey, what category did they fall under? So book reading in the U.S. by U.S. adults. So read no books at all, 395. Well, we know, based on my experiences, I know a lot of people who don't read books at all. Read only print books, 578. And again, I have a lot of friends that just love books because they like the smell of a book. So they like print books because of that. They like to hold it in their hand. They like to turn those pages physically. 91 read only digital books, which means they're talking about ebooks as well as audiobooks. And that's where I'm at right now. I read more of ebooks. I like the Kindle concept. And then read both print and digital books. And again, I would also fall in that category because I do like to hold books as well. So, but most commonly, I would be more of an ebook person, audiobook as well, depending on the book. And this was done by Pew Research. So they're fairly reputable. And this is done in 2016. So this is not that old of a survey. So I doubt that things have changed a whole lot, but I could be wrong. So anyway, what is the probability that the next person surveyed read only print books during the last year? So only print books, they're talking about this here, 578 people. So, that would be kind of when we talk about empirical probability. So let's see if I can get this pen to work here. Let's see here. Let me pause this for a second. So based on our empirical probability, the probability of the event happening, which is reading only print books, that's going to be the 578. And divided by the total frequency, well, that means the whole enchilada, all these people surveyed. So this would be like the frequency who read print books only. This is the frequency that read no books and things like that. So we have to add all four of those categories together. So I can just use my regular calculator. I don't think I need to put that all on the screen. So 395 plus then the 578 plus the 91 plus the 426. So if we add all those frequencies together, that gives us our total frequency, which is 1490. So then if we do that, I do need to I do need my calculator at this point. Let's see if I can get the calculator to come up here. All right. So if I clear that all out and put the the 578, which is the frequency of people who read only print books, if I divide it by the total frequency, which is the 1490, all of the people surveyed, if you will, that's going to give me this 0.387, or that's going to round to 3.388. So 0.388 would be that, because that 7, if I round it to 3 decimal places, has to move up to an 8. So 0.388. So about 38.8% if I was talking about a percent math. So that would be what we call empirical probability. The third type of probability is that subjective probability. Again, subjective probabilities result from intuition, educated guesses, and estimates. So not based on any real facts, just more gut feelings. So for instance, given a patient's health and extended injuries, a doctor may feel that the patient has a 90% chance of a full recovery. Or a business analyst may predict that the chance of employees of a certain company going on strike is 0.25. So, these are your armchair quarterbacks talking here sometimes. But, I would say a doctor, he's probably going to be based on past experiences, but we also know that each individual is different. So there's no guarantee that the surgery and getting a full recovery is possible. So anyway, things like this are considered subjective. So let's look at example A here. Classify each type of probability. So again, we have those 3 different types of probability: classical probability, empirical probability, or subjective probability, and explain your reasoning. So the probability that you will get an A on your next test is 0.9. So is that going to be based on any kind of real data? Is that more of a gut feeling? And for us, it's probably based on experience, but again, no hard data there is probably going to be involved. So I would say this is probably subjective. That's an opinion. That's a gut feeling. You may have been studying really hard for the tests, but we really have more of just an intuition on that than anything. So the next one is the probability that a voter chosen at random will be younger than 35 years old is 0.3. Now, remember, voters have different ages. So demographics, the people younger than 35 may not be the same thing as the people older than 35 because of those categories. So I don't think those are equally likely events. So, but this is based on probably some type of survey. So observations have been made through surveys. So this is probably going to be more what we call empirical. There's not an equal likelihood of that happening. The probability of winning a $1,000 ticket raffle with one ticket is 1 in 1,000. Yeah, notice how this has a sample space. There's 1,000 tickets, and each ticket is unique. And that one ticket being drawn is going to be 1 in 1,000. That's kind of a classical concept because I can kind of see my my actual sample space, things like that. So we have that kind of going on here. Okay, so we'll stop there on that.